Good morning, friends. Today I am going to discuss how to analyze the velocities of the slider crank mechanism with the help of instantaneous center. So, assume the dimensions of the links are known for the slider crank mechanism. So, for this given slider crank mechanism, there is only 1 degree freedom system. So, it is enough to define only one angular velocity of the crank. So no need to define any other angular velocities. So for a given mechanism, the motor is fixed at O2 and the angular velocity given to link O2A. So the output velocity can be attained at the slider. So for this slider crank mechanism, the velocity analysis consists of two steps. First, finding the instantaneous center. The second one is finding velocities. Now, consider this slider crank mechanism. We know all the lengths of the link and also we know the angular velocity of crank O2A. So for the given configuration, we are going to perform velocity analysis by using instantaneous center method. So in the instantaneous center method, first we have to define how many number of instantaneous centers present for this configuration. Before going to determine the number of instantaneous centers for this configuration, we have to find out how many links present in this mechanism. So first consider O to O4 is assumed to be fixed link and it is known as link 1, and the red color one O to A represents link 2, and the slider in the green color represents link 3, and other link in the blue color represents link 4. So total we are having 4 links. The number of instantaneous centers is determined by using the formula n into n minus 1 by 2. So n is 4, so we'll be having 6 number of instantaneous center. So to determine the instantaneous centers, we have to draw a circle and divide this circle into n number of equal parts, where n is number of links present in the mechanism. First, if we identify any instantaneous center, join that two numbers in this circle so that we can mark all the instantaneous presence for this mechanism. So first we identify the number of instantaneous centers. Okay, now consider O2 O4 is connected with link 2 by a revolute joint. So this revolute joint or O2 will be defined as I12. It is a first instantaneous center. Okay, as you define this, you have to join the link 1 and 2. So it represents instantaneous center 1 2. Next, this link 2 is connected to slider at point A, which is on slider. So link 2 is connected to link 3 at point A and forms a revolute pair at that point. So this forms instantaneous center I23. Now this slider which is in green color having a sliding pair with respect to the blue color one. Okay, for having this, then the instantaneous center of the link 3 and link 4 is at infinity, which is perpendicular to the link. So I34 is at infinity in the direction perpendicular to the blue link. Next, the link 4 and link 1 is connected at O4. So the instantaneous center of blue link and this fixed link is at O4. So this instantaneous center is I14. Okay, now if we see, we have identified 4 instantaneous centers, that is I12, which is connected. So this in the circle it is connected 1 2. So we know I12, so you just directly connect 1 2. We know 2 3, so also connect 2 3. And we have to, we know 3 4, which is at infinity, so we also know 3 4. So next I14, we also know I14, so we have connected I14. Now we have to determine I13. Okay, to determine I13, the I13 lies on a line joining I12 and I23. The I13 lies on intersection of line joining I12, I23 and line joining I14 and I43. Similarly, the I24 is another instantaneous 6 instantaneous center which lies on a line joining I23 and I34 and line joining I12 and I14. It means the I24 is the instantaneous center which lies on the intersection of lines joining I23 and I34 and line I12 and I14. Now we are going to see how to determine that I13 as well as I24. So total 4 already pointed and the remaining 2 we have to determine. Now we are going to see how to determine that. Now as we seen, I have to determine I1. Now I have to determine I13. To determine I13, we have to draw a line joining I12 and I23 and I14 and I43. First, I am going to draw a line joining I14 and I34. So I34 is at infinity. So draw a line passing through I14 and joins which is at infinity. You just draw a line passing through O4 and which is perpendicular to this blue link. Okay, this is the line joining I14 and I43. Now we have to find out the line joining I12 and I23. So this is I23 and this is I12. You extend this line, okay, so that it will intersect the I14 and I34 line. The intersection point is defined as I13. Okay, this is I13. Next, I have to determine I24. So to determine I24, now we have to join I23 and I34. I34 which is at infinity. So you have to draw a line passing through A and perpendicular to the blue link. So that this line meets the I34 infinity perpendicular to the blue link. So this is the line joins I23 and I34. Now the other line which joins, okay, I12 and I14. Now we have to draw a other line which joins I12 I14. So which intersect at this point. This point is defined as I24. These are the 6 instantaneous centers that we found. Next step is to determine the velocities of any point on the mechanism. Now first, here we know the velocity of link A. If you know the velocity of link A, how will you determine the velocity of link A? Sorry, the velocity of A is determined by using this formula. If OA or O1A is the link, have an angular velocity omega 2, then if you assume the point A lies on the link, then the velocity of A is defined as angular velocity into length of this link, where the R A I12 represents length of this red link. The length of this red link multiplied with the angular velocity will give the magnitude of velocity A. and this velocity a, to find out the direction of velocity a, you have to rotate this link by 90 degrees in the direction of omega 2, so that you can get the direction of velocity of a, direction of velocity of a. Now, and the same point a is also this, if you assume the same point is also rotating with respect to I13, because the body 3, the point A is lies on body 3, which is going to rotate about the instantaneous center I13. So to determine the velocity of A, we are taking VA is equal to omega 3 into length between I13 and A, that we are defining as RA I13, where omega 3 is defined as angular velocity of A with respect to I13. Since we know the velocity of A, we can able to determine omega 3 from this equation. Once if we know the omega 3, and this link 3 is connected with link 4 by slider joint. If it is connected to slider joint, it doesn't have any relative angular velocity. Okay, relative angular velocity between these two members is 0. So the angular velocity of this slider is equal to the angular velocity of this member. So if we know the angular velocity of this slider with respect to I13, it is equal to the angular velocity of this slider with respect to the O4. Now omega 4 is equal to omega 3, where omega 4 is the angular velocity of the output link, that is the blue link here. Okay, this is the, because it is rotating in anti-clockwise direction, we are having the velocity. If you see here, the velocity of A is acting in this red direction. Why? Because omega t is act in rotating in anti-clockwise direction. So we have to rotate this link 90 degrees in the anti-clockwise direction. So this gives the velocity of A, direction of velocity of A, and the magnitude is omega 2 into length of the link I1 to A. Okay. Similarly, the slider also rotates about I13 with the angular velocity of omega 3. So we'll be having omega 3 into length between I13 and A, so that we can determine the velocity of A. So we know this velocity VA. From this we can able to find out the omega 3. Omega 3 is equal to omega 4, because omega 3, this slider is sliding along this link. So the angular velocity of the slider with respect to the fixed member, fixed member is same as the angular velocity of this blue link. Okay. Next, now we know the velocity of output link omega 4. So we are going to follow a different method which will determine the output link angular velocity. Now we can follow the different method, that is I24 is assumed to be lying on the link 2. Then the velocity of I24 is equal to omega 2 into distance between I24 and I12, and that is defined as Ri24 and Ri12, so that we can determine the velocity of I24, and also assume the same point I24 lies on the link 4. You have to assume this point is also lies on the blue link. If you are assuming this point lies on the link 4, then the velocity of this point with respect to I14 is equal to angular velocity of this slide of this blue link multiplied by the distance between I24 and I41. So that is equal to, so I24 with respect to I12 is equal to velocity of I24 with respect to I41. Velocity of I24 with respect to I12 is equal to velocity of I24 with respect to I14. So from this we can able to find out omega 4. We can able to find out omega 4 because we know omega 2 and we know this length, so we can able to, and we can also know this length, so we can able to determine the output link velocity. Okay, thank you. We'll meet in the next lecture.